Hello students, in this lecture we have come to the last part of chapter 5, that is we are going to see integration by the method of partial fractions. So far we have learned at least about two methods of integration. One was substitution, the method of substitution, where we substituted the variable for some other value, and one more method we learned, which is known as integration by parts. Now there might come situations where you can neither substitute nor can you apply integration by parts. So for such situations we have a third method which is known as integration by partial fractions. Now let us see further regarding partial fractions. Now what is a polynomial? You have learned about a polynomial in your previous smaller classes which is there. They are expressions of this type, isn't it? Where say x plus 1 or x square minus 2x plus 1 or x cube minus 5 are different types of polynomials. Okay. Now suppose we have fx and gx as two polynomials. Then the expression fx upon gx, we call it commonly as a fraction, and this expression is known as a rational function as long as the denominator is not equal to 0. As long as gx is not equal to 0, fx upon gx becomes a rational function. Now, suppose the degree of fx is less than the degree of gx. Now, what is the meaning of degree of a function? Yes, the highest power to which the variable can be raised is known as the degree of that function. Okay, so if the degree of the numerator is less than the degree of the denominator, then the function, that is fx upon gx, which is a rational function, is known as a proper rational function. On the other hand, if the degree of the numerator fx is greater than or equal to the degree of the denominator gx, then we say that fx upon gx is an improper rational function. Now, when we get an improper rational function, what we do is that we divide the numerator, that is fx, by the denominator gx, and then fx upon gx, that is a rational function, is written as quotient plus remainder upon gx. Fx upon gx is equal to whatever answer we get during the division plus the remainder upon gx. We have come across such sums also, very few, but we have come across such sums in this lesson so far. Before going on to sums, we have to first see what type of rational form the question can be and what type of form do we have to convert it into. So, if the question is in the rational form, we convert it into the partial form. Okay. So, suppose the question is px plus or minus q upon x minus a into x minus b. This is the most common type of question which can come to you even as an MCQ. In that case, we convert this rational form into partial form by writing a upon, the fraction is written as a upon x minus a plus b upon x minus b. And then we go on to find out what is the value of a and b in this case. Then, secondly, suppose the question is px square plus qx, plus or minus qx of course, and plus or minus r upon x minus a, x minus b into x minus c. Then we convert it into this partial form. That is, it becomes a upon x minus a plus b upon x minus b plus c upon x minus c. Then similarly, suppose we have px plus or minus q upon x minus a the whole square. Then we convert it into a upon x minus a plus b upon x minus a the whole square. In each form, we find out a, b and c wherever required and then proceed further. The fourth type, if the question is px square plus or minus qx plus or minus r upon x minus a the whole square into x minus b, then we convert it as a upon x minus a plus b upon x minus a the whole square plus c upon x minus b. Then you can study the fifth one also. It is in the same way, similar way, where cube terms are given, and also the sixth one. Now, with respect to the sixth one, the denominator has one of the brackets as x minus a. The other bracket is an expression ax square plus or minus bx plus or minus c, where the second bracket is non-factorizable. It is not factorizable, and therefore we convert this expression into a upon x minus a plus bx plus c upon ax square plus or minus bx plus c. We will learn more about it when we come across such expressions in the sums which are to follow. Now we come to exercise 5.6. The first sum, the question is evaluate. The first sum in that, the integral of 2x plus 1 upon x plus 1 into x minus 2. So therefore, we write let 2x plus 1 upon x plus 1 into x minus 2 is equal to a upon x plus 1 plus b upon x minus 2. Now we cross multiply, and thus 2x plus 1 becomes, see this way, 2x plus 1 is equal to a into x plus 1 into x minus 2. Both the terms are cross multiplied with the denominator, and similarly the second term also, b into x plus 1 into x minus 2. Now what happens is x plus 1 gets cancelled over here in this term, and x minus 2 gets cancelled over here. Therefore, we get 2x plus 1 is equal to a into x minus 2 plus b into x plus 1. Upon writing this, now we take any one of these brackets as 0. Okay, suppose we write the first bracket, let x minus 2 is equal to 0. Therefore, x becomes 2, and therefore our expression becomes 2 into 2 plus 1 is equal to a into 2 minus 2. So as you can see, wherever x is there, we are putting 2. Now a into 2 minus 2 becomes 0, and so we get 5 is equal to 3b, and therefore b is equal to 5 upon 3. So thus we get the value for b. Now going further, we put the next term, that is let x plus 1 is equal to 0, and therefore we have x is equal to minus 1, and therefore 2 into minus 1 plus 1 is equal to a into minus 1 minus 2 plus b into minus 1 plus 1. Now in this case, the b term goes away because it becomes 0, and therefore we are getting minus 1 is equal to minus 3a, and therefore a becomes 1 upon 3. So we got the value for a and b. So therefore our integral now becomes, see, we have written the integral as 2, the question is 2x plus 1 upon x plus 1 into x minus 2. So now this becomes a upon x plus 1, that means 1 upon 3 upon x plus 1 plus b upon x minus 2, that is 5 upon 3 upon x minus 2 dx. Now we separate out the integrals, and therefore we are going to get 1 upon 3, the integral of 1 upon x plus 1 dx, plus 5 upon 3, the integral of 1 upon x minus 2 dx. Now remember this formula, that is the integral of 1 upon x is going to be log x. So this we are going to apply in many of our sums. So 1 upon x is log, the integral of 1 upon x dx is log x. And therefore over here the integral of 1 upon x plus 1 becomes log x plus 1. So we get 1 upon 3 log the mod of x plus 1 plus 5 upon 3 log the mod of x minus 2 plus c. Thus this sum is done by using partial fractions. Now you can do this particular sum. I am giving you one assignment to be done which you can do in your notebook along with this sum also. Okay, let us number it as 1a. Okay, the sum is this way: integral 3x minus 2 upon x minus 2 into x plus 1. Okay, and the answer, you can compare the answer once you get it. The answer is actually 1 upon 3, it is 5 upon 3 log x plus 1 plus 4 upon 3 log x minus 2 plus c. This is your answer. So you can compare it and see and try the sum out as assignment. We move on to the second question of your textbook. That is in the second sum. It is integral of 2x plus 1 upon x into x minus 1 into x minus 4 x minus 4 dx. Okay, now since there are three terms in the denominator, x, x minus 1 and x minus 4, we write it this way. So 2x plus 1 upon x into x minus 1 into x minus 4 becomes a upon x. There are three terms. So b upon x minus 1 plus c upon x minus 4. Again we cross multiply. Now when we multiply with a, all the three terms, x term goes away because it will be common in the numerator and denominator. Okay, so x term goes away. So we get x minus 1 a into x minus 1 into x minus 4. Plus when we cross multiply the denominator with b, x minus 1 goes away from the numerator and the denominator, and therefore we are going to get b into x minus 4. Plus when we cross multiply with c, the x minus 4 term goes away. So we get x into x minus 1. Now just like we did in the previous sum, we are going to write let any one of these terms, say x minus 1 is equal to 0. And therefore we get x is equal to 1. And therefore wherever x is there we put 1 over here. So we get a into 1 minus 1, 1 minus 4 plus b into 1 minus 4 plus c into 1 minus 1. Obviously wherever 1 minus 1 is there, those terms are going to cancel because they are becoming 0. And therefore we get 3 is equal to minus 3b upon solving it. Therefore b comes out as minus 1. Then we put the next bracket as 0. The next bracket say x minus 4 is equal to 0. And therefore x is equal to 4. And in this case, wherever x is there we put 4. So we get 2 into 4 plus 1. This term, it gets modified as 2 into 4 plus 1 is equal to. Now wherever x minus 4 terms are there, it becomes 4 minus 4 and so it will become 0. So the a term will get cancelled. Similarly, the b term also will get cancelled. Only c term we have left over. So c into 4 minus 1, this way. So 9 is equal to 12c. Okay, 9 is equal to 12c. Therefore, c is equal to 9 upon 12. Okay, and cancelling it, we get 3 upon 4. So, c becomes 3 upon 4. Now, how to find b? How to find a in this case? B we know, but a we have to find. For b, for a, we put x as 0. X term is left over. If you can see in the question over here, x is left over. We have not substituted x as anything yet. So, let x is equal to 0. So, in the third case, we put let x is equal to 0. Therefore, we are going to get 2 into 0 plus 1 is equal to, now in this case, the b and the c terms are going to get cancelled because they have x in them, but a term remains. So, we get a into 0 minus 1 into 0 minus 4. So, we get 1 is equal to a into 0 minus 1 is minus 1 and 0 minus 4 is minus 4. And therefore, simplifying, we get a as 1 upon 4. So, thus we got all our terms a, b and c. So, our integral becomes now integral of, now a is 1 upon 4. So, we get 1 upon 4 upon x minus, that is the b term is minus 1. So, plus minus 1 upon x minus 1 and plus the c term, c is 3 upon 4. So, 3 upon 4 upon x minus 4 dx. Just like the previous sum, we separate out the integrals. So, we get 1 upon 4 integral 1 upon x dx minus the integral of 1 upon x minus 1 dx plus 3 upon 4 the integral of 1 upon x minus 4 dx. In each case, we are going to get log as the answer. So, our final answer comes out to be 1 upon 4 log x minus log x minus 1, because 1 upon x minus 1, the integral becomes x minus log x minus 1 plus 3 upon 4 log x minus 4 plus c. So, this becomes our final answer. The third question, which is the integral of x square plus x minus 1 upon x square plus x minus 6 dx. Now, in this case, we begin this way, that is, we see that the degree of the numerator and the denominator is the same. It is x square and x square down. So, 2 is the degree of the numerator and the denominator. So, in such cases, what we do is that we adjust the denominator in the numerator like this. Now, here we observe that x square plus x term is common for the numerator and the denominator. And the third term, that is minus 1, is written like this, that is minus 6 plus 5, which is the same thing. Minus 6 plus 5 is minus 1. And then upon x square plus x minus 6. In the denominator, it remains the same. Now, here what happens is that these three terms are taken as 1. They are grouped as 1 and 5 is kept separate. So, now we write the integrals this way. That is integral of x square plus x minus 6 upon x square plus x minus 6 dx plus the integral of 5 upon x square plus x minus 6 dx. Okay. Upon writing this, now we cancel out these two terms from this integral so that we get the integral of 1 dx plus 5 the integral of 1 upon, now x square plus x minus 6 can be factorized and we get the factors as x plus 3 into x minus 2. You can think about it, it's a quadratic equation, so it can be factorized like this. Now what happens is that in the first case, the answer for the first integral, that is integral of 1 dx is x. Okay. What about the second integral? In the second integral, suppose we integrate it separately. Suppose this term we integrate it this way, that is we write let 1 upon x plus 3 into x minus 2 is equal to a upon x minus 3 plus b upon x minus 2. So therefore upon cross multiplying we get 1 is equal to a into x, here it is x plus 3. So a into x minus 2 because x plus 3 gets cancelled plus b into x plus 3. Okay, then afterwards we write let any one of these brackets, let x minus 2 is equal to 0. Therefore x is equal to 2. And so when we put x as 2 over here, the a term gets cancelled. So therefore we get 1 is equal to b into 2 plus 3. And therefore b becomes 1 upon 5. Similarly, the next step we write let x plus 3 is equal to 0. And therefore x is equal to minus 3. And therefore the a term now gets cancelled. When we substitute, a term gets cancelled. Minus 3 plus 3. Oh, in this case the b term gets cancelled. Minus 3 plus 3 becomes 0 for the b term. And the a term we get it this way, that is a into minus 3 minus 2. Which means a turns out as minus 1 upon 5. So coming back to our question was this, that is 1 dx plus 5 into 1 upon x plus 3 x minus 2 dx. So 1 upon x plus 3 x minus 2, now we modify. Okay, so our integral becomes again. So therefore we get I is equal to 1 dx, that is the first term 1 dx plus 5, the integral of minus 1 upon 5 upon the denominator, that is x plus 3 plus again the b term, that is 1 upon 5 upon x minus 2 dx. So now upon doing further, let us write it one more time over here, 1 dx as it is plus 5, and now we can separate out the integrals as minus 1 upon 5, the integral of x 1 upon x plus 3. Okay, so 1 upon x plus 3 plus 1 upon 5, the integral of 1 upon x minus 2 dx. Dx in both the cases. Then now the integral of 1 finally becomes x plus, when we open the brackets, 5 into 1 upon 5, 5 and 5 gets cancelled, and the integral of 1 upon x plus 3 is actually log x plus 3. So since there is a minus sign over there, we put a minus sign here also. So minus log mod of x plus 3, and again here 5 and 5 gets cancelled when we open the bracket, and therefore we get plus log of x minus 2 and plus c as the answer. So thus we solve this particular sum that is there. Study it properly, and then when we go to the next sum, now next sum I am giving it to you as an assignment to be done. Okay, let us write it as 3a. You can try it out so that you become more thorough in these methods. The question is x square plus 4 upon x square minus 4x plus 3 dx. Okay, and the answer I am providing for you. The answer is this, that is okay, so you can check it out whether your answer is coming proper. Now we are going to do only so many sums in this particular lecture. We'll go through this concept slowly. I hope that you will go through these 3 sums at least, do the assignment properly, and get the formula in your mind. Study the table, don't learn it by heart, but at least you become familiar with what sums are going to come depending upon what questions are going to be given. Okay, so keep safe, stay healthy. We'll meet in the next lecture when we continue with the same exercise. Do subscribe and like the channel.